Okay, good evening, everyone. We are Group GPT4PT. Our project aims to use large language model to classify MBTI type efficiently. Our motivations include help brands and platform to align their product and marketing strategies with users' MBTI type, and also speed up the current MBTI test to encourage participation, since the traditional one is too lengthy. To achieve this, we fine-tuned the GPT-2 model to classify MBTI type based on the given texture input. And then we incorporated GPT-4 model to generate some intelligent questions, which helps our user to determine their MBTI type quickly. And for the data resource, we use the existing Kaggle MBTI dataset for training. And for testing, we web scraped some data by using Selenium from this website, where the MBTI type was provided by the author. And then we did some basic data preparation, like text pre-processing and label transformation, where we split it for letter MBTI type into subcategory for our GPT-2 subclassifier to do classification separately.
To benchmark our methods that we applied to classify the MBTI types, we used the standard GPT-2 model with a linear head on top with the 16 personalities types from MBTI. For training, we used the Kaggle dataset that Fatin presented, and for testing the web scrapped data from using the Selenium library. And so this is the main system that we put in place. So we still use the GPT-2 classifiers, just with binary classification on each indicators. We train them beforehand and then use them in inference in this whole system. This is in fact a conversation in which the user is answering a GPT-4 agent questions, and these questions are based on the log probabilities of the outputs of each of the binary classifiers. And in practice, what we did is we did one indicator at a time, so probabilities of one indicator at a time, and at the end return the whole predicted MBTI type classificator on each of the indicators. Another method that we applied, and to compare this to the GPT-2 classifiers that we used in the main system, we did a method with the full GPT-4 conversation, in which it was master prompt, so a prompt dependent to compute the overall confidence in the prediction and also the confidence in each of the MBTI type indicators. And so the conversation goes on. It's a sort of chain of thoughts method. And when the overall confidence reaches 90%, the predicted MBTI type personality is returned.
Okay, so let's take a look at the results. First of all, when we look at the validation accuracy, we compare it with our baseline model. Just to recall, the baseline model is just one single GPT-2 model that has all the classification. We outperform in the validation data set. We also collected new test data set, 428 new samples, and you can see that the baseline model simply cannot generalize. And on the prompter module, we also looked into just prompt engineering a pure GPT-4 model, just as a comparison, and we achieved similar results. We had 12 participants, all different MBTI types to participate in the trial. But when we look at it closely, when we break it down, we can actually see that the pure GPT-4 model actually performs slightly better, achieving a higher accuracy earlier at 300 above correct predictions. When we look at the subclasses, we can also see that the GPT-4 model performs slightly better than our GPT4PT system. Qualitatively, we can, so here shows an example where our system is working well. You can see that when the user answers something in mutual, for example, the user said for the most part or sometimes participating, our system penalizes the confidence level. And here we also show somewhere we identify that the system isn't working very well, that the prompter can ask very similar questions to the previous already asked questions. And also the classifier penalized incorrectly on the answer, potentially based on the writing style or tone instead of the context. That's how the classifier part was trained.
To give a postmortem on the results, we can analyze data into two perspectives. One is from the semantic reasons, one is from the model selection reasons. Although our accuracy only has 33 accuracy, but it's because of the result is a joint probability. So it's exponentially decreased according to the number of types. And some types are even harder to be analyzed by the post. For example, the thinkings and the feelings, and some posts are not even available on the online posts. And also because of the self-presentation bias, the people tend to put on mask on their online persona. So the result may not accurately reflect their real personalities. So, and also there are some reasons because of the model selections. The GPT-2 has a very limited abilities on the contextual understanding. So as a result, the GPT-2 becomes a bottleneck of our accuracy. So we dive deeper and explore more on the pure GPT-4 solutions, which gives more features and more accuracies. For example, the confidence level as the metric and the type percentage as a result. More importantly, it uses the correlated questions between types. We believe if we spend more time on the GPT-4, we will reach much better results.
Thank you.